Hi guys, now it's talk about grams to moles, and so we're just starting with a slightly different portion of the problem. So let's read this one. It says gasohol is a mixture of ethanol and gasoline. Balance the equation and determine the mass of carbon dioxide produced from the combustion of 100 grams of ethanol. And I guess I'm kind of skipping the grams to moles and just going right to grams to gram. If you have a problem with grams to moles, just let me know and I would be happy to put up another video. I was having a hard time finding one that worked. So here we have 2 carbons, 6 hydrogens. So I know I'm going to have to multiply this side by 2. And I gave you that hint the other day when I was showing you how to balance these. So that gives me 12 hydrogens here. So I need a 6 here. And then I need a 2 here. And then I have 4 plus 6 is 10, and so I need a 5 here. If this had all come out the same as even numbers, then I would have to look and make sure I'd balance it correctly. So I'm going to start with what's given to me in the problem, and I'll just highlight that here. This is what they gave me. And they want to know the mass of CO2 that we will get out. Okay, so we're going to start with 100.0 grams of C2H5OH. And I'm going to make a really long line. We are going to need some molar masses, so let's kind of work those off here on the side. For C2H5OH, I'm going to have 12.01 times 2. I'm going to have 6 times 1.008. I'm going to have to add to that 16.00. And I think I'm just going to make this a little bit smaller right now. I'll make that a lot bigger. Let's see if I can get there we go. And let's get our calculator up. Let's drag this off a little bit to the side. This way I can see my calculator while I'm actually calculating. And so 12, oh, having a hard time here, aren't I? Clear. So 12.01. Okay, 12.01 times 2 plus 6 times 1.008 plus 16 equals. And so for the molar mass for ethanol, I get 46.068 grams for 1 mole of C2H5OH. C2H5OH. The other mass I'm going to need is carbon dioxide. So let's go back over here. CO2. Well, I know that carbon is 12.01 plus 16 times 2 equals 44.01. 44.01 grams CO2 for 1 mole CO2. Now I probably don't have that in the correct orientation. One of those is obviously upside down because I have moles in the denominator for both. So we'll have to see which way I need it, and I can always flip these over to make them work. And in fact, I think I'm going to have to flip over this first one I figured out because I need grams of C2H5OH in the denominator. So I'm going to use all of those for 6.068 grams of C2H5OH for 1 mole of C2H5OH. And then for my balanced chemical equation, I see for every 2 moles of ethanol, and I'm going to CO2, I get 2 moles of CO2. And again, I strongly urge and will not accept you to use a reduced fraction here. I want to see the actual ratio from the balanced chemical equation. How you put it in your calculator is up to you, but you will show me the actual ratio from the problem. And now that I've got it into moles of CO2, the last thing I need to do is get 2 grams of CO2. And so I'm sliding this over so we can see what our ratio is over here. And it says for every 1 mole of CO2, there are 44.01 grams of CO2. And so let's see what we can cancel out. We can cancel out moles of CO2. Why isn't it just drawing? Moles of CO2 with moles of CO2. Moles of ethanol with moles of ethanol. Grams of ethanol with grams of ethanol. So again, I'm ready to use my calculator. I'm going to drag this over a little bit so we can see what it looks like. And I'm calculating. And I need to make this slightly bigger. There we go. I can just see everything. That's perfect. And so I'm going to start here with 100. And again, my calculator's stupid, so I'm not going to bother to put in the 0.1 because it's just going to get rid of it. Divided by 46.068. And then I would multiply and divide by 2. So if you don't want to put that in the calculator, that's fine. I'm going to go ahead and do it. Divide by 2 times 2. And then I need to multiply anything above the line there. We would multiply by. Anything below it, we would divide by. Oh, I forgot my decimal point. 0.01 equals. And I get 95. I don't think backup works there. Nope. I'm going to have to do this a whole calculation over. Divided by 46.068 and then times 44.01 equals. Let's see if I can get over here without causing something crazy to happen there. And I get 95.5326 grams of CO2. So now we need to worry about significant figures, and I'm going to also estimate my answer. I start with 100 grams. This molar mass and this molar mass are almost the same. 44 and 46 are really close, and 2 to 2. I would expect to get an answer close to 100, and since 44 is smaller than 46, it should be slightly under 100, which is exactly what I got, so I have a good number. And now I'm going to round it to the correct significant figures. And how do I do that? Well, I have 4 significant figures here. So I need 4 significant figures in my answer. And so my final answer will be 95.53 grams of CO2. Now, I've highlighted it in a box so that you can see where it is. And I do kind of appreciate when you do that for me as well. So, I hope this one was helpful. We've got a couple more to do. Percentage yields and limiting reactants.